Standard 10th Mathematics Part 2 Chapter Trigonometry Video number 16 in Solving Practice Set Problems. So children, in trigonometry, moving on with more of practice set problems. Let's see the problems written on the board. Prove that the first one, sine raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. This is the first problem. The second problem says that left hand side show is equal to the right hand side, that is sec theta plus tan theta, we have to prove is equal to cos theta upon 1 minus sin theta. So let's begin with the first one. The first problem says, prove that sine raised to 4 theta minus cos raised to 4 theta show is equal to 1 minus 2 cos square theta. Let's begin with the left hand side. Expression, and towards your right hand side you have the expression 1 minus 2 cos square theta. Let's pen down with the left hand side and let's see how we can move on with the mathematical steps. So our left hand side expression is sine raised to 4 theta minus cos raised to 4 theta. Now children, this resembles a formula which says a square minus b square is equal to a minus b into a plus b. But over here, can we replace any term raised to the power 4 equivalent to a square minus b square? Definitely. It says that if you have an expression a raised to 4 minus b raised to 4 can be written as a square the whole square minus b square the whole square. Right? So here, let's use the same mathematical logical step for this expression on the left hand side. Sine raised to 4 theta can be written as sine square theta the whole square minus cos raised to 4 theta can be replaced as cos square theta the whole square, which ultimately definitely gives you the same step back. Why? Because sine square theta the whole square will be sine raised to 4 theta minus cos square theta the whole square again gives you cos raised to 4 theta. So undisturbing the expression on the left hand side, we have replaced a raised to 4 as a square the whole square, b square the whole square. Now children, this expression that we have simplified resembles a square minus b square formula, which can be written as a minus b into a plus b. So over here children, how will we use the formula? Over here, a square minus b square can be written as a square minus b square into bracket a square plus b square. So let's imply it over here. X square minus y square can be written as x minus y into bracket x plus y. So let's begin. X minus y into x plus y. We are just using the formula x square minus y square gives you x minus y into x plus y. Now, can sine square theta minus cos square theta be replaced by any trigonometric identity? Do we have any identity where you can replace this? Definitely children, we know what is sine square theta plus cos square theta, sin square theta plus cos square theta is equal to 1. So keeping sin square theta minus cos square theta as it is, we can replace sin square theta plus cos square theta as 1. So the first expression is kept as it is into 1. The reason is because we used which identity? Sin square theta plus cos square theta is equal to 1. So we could replace sin square theta plus cos square theta by using this identity by 1. Anything multiplied by 1 is the same term itself. 1 into sin square theta is sin square theta minus 1 into cos square theta is cos square theta. Now let's look into what is required on the right hand side. We require on the right hand side only an expression in cos square theta. There is no term saying that sin theta is required. But what have we reached to? We have reached to an expression where we have sin square theta minus cos square theta. On the right hand side we require cos square theta. How do we get rid of this sin square theta? Because it is not required in the right hand side. So definitely again let's reuse the trigonometric identity which replaces sin square theta by cos square theta. And which is that trigonometric identity? Sin square theta plus cos square theta is equal to 1. So what can we replace sin square theta as? Sin square theta will be equal to 1 plus cos square theta goes on the other side. So it takes a negative value. So sin square theta is equal to 1 minus cos square theta. So over here sin square theta can be replaced as 1 minus cos square theta minus, let's not forget to write this term as it is. So over here what are we left with now, children? Like terms we can add or subtract depending upon the sign before it. So minus 1 cos square theta minus 1 cos square theta gives us minus 2 cos square theta. So 1 minus 2 cos square theta. This is equal to your right hand side. So children, we were able to prove starting with our left hand side, giving us a simplified step or an expression where it tallies with our right hand side. And if we can see, we have just used our basic maths. Just one formula, a square minus b square is a minus b into a plus b. And only one trigonometric identity which helps us to solve left hand side equal to our right hand side. Therefore, we can say that our left hand side is equal to our right hand side. Thus, sin raised to 4 theta minus cos raised to 4 theta is equal to 1 minus 2 cos square theta. We have proved finally that the left hand side is equal to a right hand side. Now children, the second one which is given on the board. Let's start with the second one. Which is given on the board. Which says, prove that sec theta plus tan theta sure is equal to cos theta upon 1 minus sin theta. Now children, let's look at the left hand side expression. And this is the expression towards your right hand side. As usual, let's begin with the left hand side. Let's pen it down. Sec theta plus tan theta. If recalled, it is seen earlier, wherever you have such inverse ratios, In the numerator, only the numerator over here, without any denominator, it is always advisable to change it into the basic functions. Those are sine and cos. So let's change them or substitute them with their inverses. Now we know what is sec theta. Sec theta is 1 upon cos theta. What is tan theta? Tan theta is sin theta upon cos theta. Let's write down the reason as sec theta is equal to 1 upon cos theta and tan theta is equal to sin theta upon cos theta. So, over here children, now what do we have? We have two terms, a binomial. Let's put them under a common denominator. The common denominator is cos theta. Numerator will be written as it is because both the denominators are equal to the LCM. So 1 plus sin theta. Now children, as earlier told, we have been left with an expression where we have only the basic functions sine and cos. Now what do we do? Is it equal to our right hand side? Definitely not. On the right hand side, we have to prove that this left hand side is equal to cos theta upon 1 minus sin theta. But what have we got? It's not equal. So what do we do? Let's compare it with what they require. The requirement in the denominator is 1 minus sin theta. So let's rack our brains. How do we get 1 minus sin theta in the denominator? Definitely, we'll have to multiply the denominator with whatever is the requirement in the right hand side for the denominator. What is required? 1 minus sin theta. So let's immediately multiply the denominator with the requirement 1 minus sin theta. Whatever you multiply in the denominator, whatever operation you perform in the denominator should also be applicable for the numerator. So let's multiply the same in the numerator. Now children, if we look in the numerator, can we use a formula? This resembles a plus b into a minus b. So what is a plus b into a minus b? Again, it gives us which expression? A square minus b square. So what do we get for 1 plus sin theta into 1 minus sin theta? It is a square, that is 1 square, which is 1, minus b square. What is b over here? Sin theta. So sin theta the whole square is sin square theta upon the denominator. What is in the denominator? Let's write it down. Cos theta into 1 minus sin theta. Let's move on. So over here children, what do we get now? 1 minus sin square theta again. Can we replace it with by using any trigonometric identity? Yes, definitely we know that sin square theta plus cos square theta is equal to 1. So what is 1 minus sin square theta? 1 minus sin square theta will be equal to cos square theta. So let's replace the numerator 1 minus sin square theta by cos square theta upon cos theta into 1 minus sin theta. Can we reduce? Definitely. 1 cos theta gets reduced. So we are just left with cos theta upon 1 minus sin theta. Is it tallying with the right hand side? Yes, definitely. It is equal to cos theta upon 1 minus sin theta. This is equal to your right hand side. So we were able to prove left hand side is equal to right hand side. Thus, sec theta plus tan theta, we have proved is equal to cos theta upon 1 minus sin theta. Proved. So children, we were able to prove again that the left hand side sec theta plus tan theta is equal to cos theta upon 1 minus sin theta. How did we move on with our calculations or mathematical steps? Wherever we have such inverse trigonometric functions, as far as possible it is advisable to change it into their basic sine and cos, and then move on by using trigonometric identities and mathematical logical steps to prove the left hand side is equal to the right hand side.